to try some of this stuff out. This was this growth and decay stuff that we've been using. Kind of focusing in on this setup right here and doing both. Writing the model by leaving t in there and then dropping it in. Okay? And so you're going to see, they don't, like on these questions, I've got some stuff for us printed out so you guys don't have to write quite as much down. I don't think, except for once, do they even say to write the model, but you're going to do that. So there's not a lot of space because you don't need a lot of space. Write down the model, write it with the number going in, plug it in your calculator, and round to whatever you need to if you round, right? If it's money, we'll go to 2 decimal places. If it's any like living, breathing kind of thing, if you're counting something that really can't be chopped in half or anything like that, then we'll just round to the nearest whole number. And I just want to give you a chance to try it out. Before we move on and start messing with, the actual scenarios with what happens with like how banks are going to compound interest and how to make more money on your money, stuff like that. So what you'll see in here are a lot of questions that look like this, okay? Where they give you a rate, they give you a starting amount, and they give you time. You just got to plug it in. Now, once you get onto the back, we can only do the top one. So 1 through 7 on the front, good to go. Number 8 on the back is good. But 9, 10, 11, and 12, we cannot answer those yet. Number 9 is all about that compound interest, so we'll skip that one for now. But don't cross them off. We'll come back to them. And then 10, it like leaves t in there and asks us to solve for that, and we don't know how to do that yet. Okay? So I'm going to get this out to you. But take out a calculator so you can, which might just be on your phone. That's cool. I don't know that you'll need to take out your notes as well because it's just sitting right there. That's the formula we're going to use over and over and over again. But I'm going to call this classwork 4.4. Get it done today, put it up on campus. Then tomorrow we can do compound interest. Sure.
Do we have to use that formula?
I don't know of any other way to do it. That's the thing.
I'm just like, I don't know, I'm just really good at it.
I know you are. That's right. So, I mean, if you just figure out another way, sure. But, I mean, you look at these, and I have the answers done too. I'll put them up behind you guys so you can see it. And I'll put it on Canvas too so you guys can check them out. I want you to just do your best here and see what you can get. But, the first one's about money. That's cool. Second one's about people, and how many cell phone subscribers are there. And be careful with what you put in this exponent. Okay, once you write the model first, and then you figure out what number to put in there, think about how much time has passed. That's what you want to put. Like, how many years has it been? How many minutes has it? Whatever it is. Yeah. For sure. Yeah. You guys can talk this out together. You can work on it on your own. This is all you have to do today. Okay, we're not making anything else. Sure. So, why don't we can do the first one together. How about that?
Yeah.
Let's do the first one together. So I'm going to leave this formula right here so I've got a spot. I'll write some stuff next to it. Okay. All right, this one's talking about money, but they don't say anything about compounding interest. So we're in luck. We don't have to use anything but that formula right there. And all we have to do is figure out first, again, we're going to do 2 things. It doesn't say to, but we're always going to do it. We're going to write the model in terms of t first. So it's just going to be a of t equals. Now leave some space, right? So put this as far left in the space underneath number 1 if you can. Let's see what we got. All right, find the bank account balance. The balance is just how much money is sitting in. If the account starts with $100, has an annual rate, so the interest is 4%, and they want to figure out how much money is in there 12 years later. So let's write it where we don't put the 12 in for time just yet. The first thing after the equal sign, P, your principal, whatever you're starting with. So how much are we starting with?
100.
100? Okay, so right after the equal sign is the number 100, and then we open up the parentheses. Okay. Then just the number 1. And it's just a 1. You don't have to write your 1 like that. I want you to know how I do that. Okay. And we have to decide: are things going up or are things going down? We're putting money into a bank account. They're going to pay us interest. Is our balance going to go up or is it going to go down? We're making money, so let's choose plus. You'll see that there's going to be questions in here where things are going down. Okay, and so you want to make sure that you choose minus in that spot. All right, now comes the rate. What was the rate that they gave us? 4%. Now we don't have a percent button in our calculator, so we have to make the switch and write 4% as a decimal. Again, when you think of percents, don't think of percent. Think dollars and cents. In my mind, I don't think 4%. I think $0.04. 0.04. And again, just leave it with the T for now. That is the model in terms of T, where we don't actually drop in a number just yet. Okay. Now, separate your work because we don't really have vertical space. Put a little, I don't know, put like a little squiggly. Now we can actually change T and see what we get. So part A, the first thing we'll always do, write the model in terms of T, just leave T as T. Then, second time through, we'll drop in whatever time they're giving us. How long has it been? 12. There it is. 12 years. They gave us an annual rate. You know what the word annual means? Yearly, once per year. So it's nice that those match up. That's good. And the only thing I do is I rewrite it with the 12 right there in for T. Like I changed T to 12 in the first one, I better change it everywhere. There's only ever one T. And now let's see what that is. Straight to the calculator, no question about it. I'm gonna let it do the work for me. Where is it? There it is. So I'm jumping on the Calc 84 app. I like that one. No, I'm not gonna upgrade. Sorry about it. 100 parentheses. Just the right side, just to stuff the numbers. 1 plus 0.04 to the power of 12. Now we can round right away. I know yesterday we were writing out the numbers and then rounding. It's sitting right there, right? Just round it. How many decimal places are we talking money? Dollars and cents? Okay. Now mine says 160.10322. Do you guys get that? Okay, cool. So 2 decimal places, so 103, right? So that would be the third one. So when we think about rounding this and we're talking about money, all right, 160 points, does it stay 10 or does it get bumped up to 11? The next number needs to be at least a 5 if I'm going to bump it up. It's a 3, so $160.10. No, let's do 2 together. This will be different too, which will be good. But that's it. Write the model, drop in the number the second time through, plug it right into the calculator right away, round it up. Let's do it. Green is green. Right. So
on that one, do you have to like add the 160 to the starting 100?
No, this will always give you the final amount, which is nice. You don't have to go back to the original and say, let me add the 100. And really, the way that it's doing that is by doing 1 plus. If it was just the 0.04, then we'd have to go back and add the 100. Yeah. But by including the 1 plus, it's like I got 100% plus an extra 4%. So I'm going to take my 100. And so if you just did like 4% of 100, 12 times, you would get 60 cents. But the 1 plus adds that 100 back in force, which is why I like this formula a lot, because I don't have to do any of that extra. All right, cool. Number 2. In 1985, man, that was a good year. When I was born. I know, old man. There were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Centerville in 1994? All right, so let's just set it up first. A of T. So I'm not putting any of the time stuff in, so I really just need two parts. I need to know where I'm starting at, and I need to know that rate, whether we're going up or going down. So 285, right? That's how many people we started with that were subscribed to a cell phone service.
Does it always have the one right there?
Always, always, always. One, and then we make a choice. Plus or minus, depending on the setup. What word in here tells you it's plus? You're going to look for that kind of word, right? Increase or decrease. Doubling versus being cut in half, things like that, whatever it is. Okay, so 1 plus 75%. There's that rate. 0.75. If you like to put the leading zero, I'm a big fan of it. You don't need it, but you got to know that it's 0.75. And then just lead T. Just like that. There's that little squiggle to separate it. And now everything's going to be the same, except we'll drop in that number. However long it's been.
So to get T, would you just subtract the 2 years?
Yeah. I'm not going to put 1994. It hasn't been 1,994 years since the start. This started in 1885. They want to see what's going on in 1994.
9.
So how many years has it been? 9. From 1985 to 1994? No, from 85 to 94. They didn't say like present day. 9 years. 9 years. So that's a 9 right there. So this is a 9 right here. Oh, I forgot. Oh my goodness, I forgot the 285. Nobody stopped me. 285 right after that. Then I plug it in. Now, sometimes it'll work out where I don't even have to round. Maybe it's perfect. But I'm going to check first. I figure out what I did. I type in that whole right side exactly as it's written, 285, parentheses 1 plus 0.07 or 0.75 to the power of 9. 75% is a lot. Right? That's a really, really big increase. And we get to do it for 9 years. So although we started at 285, you guys get over 43,000. 43871.
Yep.
0.9863. Yep. So what are we rounding to there if we're talking about people?
Whole number.
Here's whole number. Okay, no decimal. So 43,872. 1 or 2? 2. It's because 1.9, right? That 9 is bigger than, it's 5 or bigger. So 5 or above, give it a shove. 43,872. Now we put a unit right there, right, money? 43,872 what?
Cell phone subscribers.
Cell phone subscribers. Always, always, always put the unit. Subscribers. You have what I said? Yes. You can put subscribers, just you don't have to say cell phone, you can just say subscribers, but yeah, we gotta figure out what we're counting. Now, the thing that we have not really talked a lot about is, what if they don't give us a rate as a percent? What if they just give us the setup like they do for number 3? What's the key word you think in number 3 for how things are changing? Multiply for sure. Okay, right back here, I can multiply at an alarming rate. Double. So it's not that my rate is 2 necessarily. It's that all of this, right? My multiplier is going to be 2, right? This whole thing altogether, whatever the base is, we can call that our multiplier, right? Also known as a growth factor. And so it's not that I'm going to put 2 in for R. It's really a rate of 100%. When you think about doubling, what happens is that we're increasing every time by 100%, which is just the number 1. 1 plus 1 is 2. And so your setup for 3 might be a little unnerving when you talk about saying, all right, if I want to figure out what this setup is going to look like, right? Right, each bacteria can split into 2 new cells, thus doubling. If we start with only 1 bacteria, so there's my principle, starting with 1, but we're doubling every time, this number in here is 2, which is 1 plus 1 at rate of 100%. That can be a little tricky. So if they say triple, okay, put a 3 right there. Cut in half, okay, cool, put a 1/2. But just to the power of 2. Well, let's think about it. Read it again. Bacteria can multiply at an alarming rate. When each bacteria splits into 2 new cells, thus double. We start with 1 bacteria, which can double every hour. Now it's not days or years, right? It's hours. When we talk about doubling, time in my mind is now in hours. But look how long they asked us to go. How many bacteria will we have by the end of 1 day?
24.
We need it to go back to hours. This is not A of 1 day. This is A of 24 hours. Be careful. Try to do that. Try to like mix and match a little bit. Really, we're going to type it in like this. 1 times 2 to the 24. Now, I don't see any decimals in there, so I'm feeling pretty good about not having to worry about rounding. Let's see if it works out. 1, don't really need it, but I'll put it there. Times 2 to the power of 24. Okay, start with 1 and let them double once an hour. And just in 1 day, put the commas if it helps. Over 16,777,216 what? Are we counting?
So,
Bacteria. You can just say bacteria. That's good. 4 cells, 4 bacteria. That's all.
I have a question.
Great,
Like,
please.
it's kind of stupid, like for the first one, why can't you just do like $100? Times that by 0.04, and that would be like 4% of 100.
Right.
And then times that by 12 years. Find out like
It's not times 12, it's that I'm going to get 4% 12 years in a row. And so we don't want to just multiply it by 12, I want to raise it to the 12th power. Yeah, we need the exponent so it's repeated multiplication. So it's like 0.04 times 0.04 times 0.04 times, like you have to do it 12 different times. And the exponent will just make that happen for us. This is fast. Instead of like typing, like, remember when we did properties of exponents day 1? I was like, okay, what is x squared? Oh, x times x. What's x cubed? X times x times x, right? It's the same thing here. We just don't want to write out the long way so we can save ourselves. All right, there you go. So there's the first 3. Hopefully that'll kind of get you started. 4, 5, 6, 7, and 8, and then stop. Yeah, get just the 8 done and then turn it in. I'm going to put the answers up back here so you can check them out in case you want to see if you're right. I'll do this. Yeah, it's today. So we've got half hour to do like 5 more questions, 6 more questions. Talk it out, ask me questions, take a look at the answers once you're ready for it. Yes, sir. Let's see how we did on the first 3. Yes. That looks real good. Rounding, and then exactly. Yep. Nice. All right. There's 4, 5, 6, and 7. You can see those, and then right at the end, I'll flip one on the back and do 8. Folks at home, let me get you guys the solutions as well. Check them out. And yeah, when you're done, this is classwork, I think 4.4, I think I called it. And so just put that on Canvas when you're done. I'm gonna drop that right in the chat. Yeah.
So for, four,
Yeah.
it says, every round half the players are eliminated.
Yeah.
So it's like the same thing we just did, but backwards.
Go backwards, yeah. So now we're gonna use the minus. And you could like put the rate in as 50%,
Okay,
or you can even just put like 1/2 right here. Like that's mine.
How should I write it then right here?
Either way is fine. You can put like 1 minus 1/2
Okay.
or 1 minus 0.5. Yeah, anything like that's good.
5 rounds.
That's time, yeah, because like what we're keeping track of is like number of rounds played, yeah. So time passing doesn't have to be minutes, hours, days. Yeah, it can just be like how much. Yeah, weird to think about it like that and be the same thing. Yep. So be careful when they mess with stuff like that. Number 5, they actually give us the formula and ask us to figure some things out. Right? What's the population at a certain time? And what percent is that increase? Right? And you kind of want to look at that growth factor. Right? Look at that multiplier and do some deductive reasoning there. The 5 is unique in that they're giving us the formula. We've got to like think about what it is.
You check my
Answers are behind you. So you guys can check those out, see how you're doing as you go. Yeah, what's the time? Yeah.
I don't know which one is that.
Oh yeah, 7 is so gross because 0.88, right? So 1 minus 0.12, but to the 240th, we get this thing in the calculator that I don't know if we've really talked a ton about. Numbers that are like too big to fit in the calculator or too small to fit in the calculator. Let me erase this stuff right here. There's something that'll happen. Let me look at how it looks in Calc 84. 500, 1 minus 0.12 to the power of 240. So, yeah. 500, 1 minus 0.12 to the 240. Why am I getting a, oh. Come on, why are you doing that? That's okay. So my calculator is not doing scientific notation very well. It's supposed to be only one number before the decimal. So there's 2 possibilities here. Could be that, or, which is what it should be, 1 decimal place, and then everything after that times 10 to the negative 11. But here's the thing, it probably doesn't show up like that. It probably says E negative 11, right? That means times 10 to the negative 11. Scientific notation. I just leave it like that.
Okay.
If you want to like stop, how many decimals should we write down? I don't know. I mean, the more you put, the better. But realistically, like 3 or 4 is enough. Yeah, 4 is always safe. I know for me in AP Calc, we need 3. 3 is bare minimum, so 4 is usually pretty good. So you can say something like 2.370, like approximately, times 10 to the negative 11. What are you? Milliliters? Milliliters. Now I don't know why it's doing it with 2, like scientific notation is supposed to be 1 number, decimal point, and everything else, and then you tell us what to move. This really means like move this decimal 11 times to the left, the negative direction. That's 0.00000001. But use scientific notation. Way easier that way. That usually doesn't happen, but that's sometimes. So they're already giving us the setup, and they're kind of looking at this question with number 5 and they're saying, okay, here's the formula. Can you figure out like what my starting number was? Can I figure out what my interest rate is by like already looking at the setup and trying to pull out the important number? So when you look at that setup, they went P equals because they were talking about population, right? So that's what that P stands for, which is a little misleading, but all right, T is the number of years since 1990. What is the population in 1990? Like no time has passed. Like where did they start? What part of that formula is the starting amount?
Starting percent?
No, like how many people, right? So they're talking about this population of this town in Nevada. They give us the model, 6191 times 1.04 to the T. And they're asking us, what's the population at the beginning?
6191.
And so that's what I wrote. Look up here. What's that? Population 6191. I wrote it. Oh. That's crazy. Here, like if you can't fix it, let me know. And then they say, okay, what's the population increase? Like, what is the rate? What's the percent that it grew by every year? Well, if the inside is 1.04, what is the rate that we added to 1 to get to 1.04? So like looking at the formula they gave us and trying to pull out the important info, we just write it, yeah.
Can we just look back here?
Exactly. I think that's what they want us to do, is they want us to like look at the formula and just figure it out. Not like plugging anything in. 5 is unique in that we're not like plugging in a time and figuring out how many. They're like, here's the formula, work backwards. Where did this formula come from?
You just got to figure out which numbers to work.
Which numbers do which? Yeah, put it on canvas when you're done. Yeah. Classwork 4.4, I believe. Make sure 1 through 7 on the front and then 8 on the back. Still bugging? Yes and yes. It's safe to go 4 decimals because it's not about like milligrams. And so it's not money, so it's not 2. It's not living, breathing anything, so I'm not going to whole numbers. So I like 4 decimals. That's super accurate. 4 decimals is so like the level of accuracy to go 4 decimals is really, really good. Yes. Let me use this. Are you lefty? You're right-handed, right? Yeah, because I have both. All right, Oakland, keep going. Okay, great.
Yeah, I don't know what I did. Like I like to look over and then
That was my first attempt. That did not work. Here's my second idea. Plug it into the charger and see what it does. It starts going fast. Oh, it won't even turn off. That's interesting. Yeah, the calculator is not happy right now. Did you like spill anything on it, like drop your backpack or anything? Like, was it working and then it just stops?
yeah.
Okay. Oh, what I'm gonna do is I'm gonna take it home. If you will let me, because I don't have my mini screwdriver here. I got it at home actually. Mine? No, I did. Yeah, pick it up. I got a little screwdriver at home. I can take this off, maybe disconnect and reconnect the thing. But you might want to prepare for the worst. Situation like that. But we'll let it charge. We'll see what happens. I'll take it home with me. I'll play with it a little bit. We'll do some calculator surgery. The doctor is in. I just decided, sometimes we just leave it, 1 plus 0.75. Sometimes I just add them together, and I can call it 1.7. So with something like 7, you can do it whenever you want. You can leave it separated. For me, like number 7, right? 1 minus 0.12 because I'm decreasing by 12%. All right, well, what is that? Well, 1 minus 0.12 is 0.8.
Oh, okay.
So sometimes I just leave it because I just don't really need to put them together because I don't feel like it. Like, number 6, 1 plus 0.05. But why write 2 numbers when I can do it? I like to do that simplification. And you're going to see when we start answering the question, like, how long does it take to get to 700 people or whatever? I know the start, I know the end, but I don't know how long it took. When we start answering the question of solving for the variable in the exponent, which we don't know how to do yet, it's going to be just a little bit easier if it's just 1 number. Let's have a base that's not 2 numbers being added or subtracted. Let's actually add.
You just did a total of 1 minus 1.75.
Yeah.
Okay.
And I don't know if I do that everywhere. Let's see. Like, yeah, sometimes, like number 2, I just flexed it. 1 plus 0.07. Or 0.2. Sometimes I say, you know what? Why leave them separated? Might as well put them together. And that's it. Once you get those 8 done, you are good to go. We have about 15 minutes. Yeah.
Are you able to explain the bell schedule for next week? Like,
Yes. Sure. Yep. Absolutely. Let me just find it. Monday is a regular day. Monday is regular Monday. I guess it would be coming from Miss Hogan. She's testing lady. There.
Can I interrupt you?
Yes. There we go. So Monday's regular. Lunch is like any other Monday. I'll see you guys after lunch. Tuesday, Wednesday, Thursday. 10.
Tuesday, Wednesday.
Right. It goes 11, 10, 9. Okay. SAT for juniors, SAT 10 for 10th graders, SAT 9 for freshmen. That's going to happen in the morning at the same time. You only come in on your day. So you're only going to be in school at most Tuesday or Wednesday or Thursday. Okay.
Including the Monday, probably.
Everybody comes in Monday. So don't even count Monday as being part of testing week. Testing week is just the 3 days before it.
This is next week, right?
What's that?
This is next week?
Yeah.
You are automatically registered for the SAT and you must. Yeah. It's part of the graduation requirement. Yeah. But whether your plan is to use that test or not to get into whatever's next is anytime you still have to.
I wouldn't do it all like that.
You do not come to school. Like if you're a junior, I will see you Monday and Tuesday. If you're a sophomore, I'll see you Monday and Wednesday. Or you'll be in school Monday and Wednesday. If you're a junior, you'll be in school Monday and Tuesday. If you're a freshman, which you don't have anything here, but Monday and Thursday. If you're a senior, you only come to school on Monday. That's it. However, in the afternoons on Tuesday, Wednesday, and Thursday, you have remote classes. So no matter what, you go home after your test gets up, and you stay at home. And then you'll jump on to Google Meet with each of your teachers just once over those 3 days. So we're only going to see each other Monday, and then for 25 minutes on Wednesday. That's it. Very little.
I don't know what I did wrong.
Attendance and a little practice. That's about it. Yeah.
I don't know what I did wrong.
You have like 10 minutes.
Thanks for telling me.
Yeah, sure. Did that answer your question?
Yeah.
Cool. And I'll keep reminding you as we go.
Yep.
Okay, so E is the calculator's attempt at scientific notation. When numbers are too big or too small, they can't fit enough zeros. Basically,
So that is the correct number?
Yeah. So when you see 2.37 blah, 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 E negative 11, that really means times 10 to the negative 11. Which means move this decimal 11 times in the negative direction. 0.00000, like super, super tiny. We'll just write it using scientific notation, and I like 4 decimals just to be safe. So 3703, okay, below 5, so I keep it, and then times 10 to the negative 11. Or if you really want to, 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 3, 7, 8. That is how small that number is. So if the number after the E is negative, it's super small. If the number after the E is positive, it's really big. So I like this version, but that's what it really means.
Yeah, I like that. That's the one.
Yeah. The app gave me this one, which I thought was kind of weird. The scientific notation is just single digit decimal place and then your decimal. It was weird that the calculator in my phone gave me 2 numbers, then a decimal. So there's a negative 12, move it 1, 2, 3, 4, 5.
And then the negative 11 and the negative 12 is put up as an exponent.
Yeah, it's an exponent, yeah. And negative exponents means 1 over, right? Reciprocal, that's why it's so tiny, because we have like 1 over 23 trillion or bajillion, whatever, out there, they got numbers, this is why it's so small.
Thank you.
Yep. Okay, if you need me to scroll and check out any of these answers, let me know. But we're going to do 9 tomorrow. We'll learn about compound interest. 10, 11, and 12, we won't be able to do until we actually start solving exponential equations, which I'm going to do after our interest conversation. We're going to focus just on the percent growth and decay, plugging stuff in. Yeah. Classwork 4.4. 5, just like a regular homework. Yeah. Yeah.
I'm not sure to.
So 5's kind of weird because they're not asking us to like figure out like how many there are 10 years from now, right? But they already gave us the formula. Like there it is. I know they called it P equals instead of A of T because it's population. They can that's them picking whatever letter they want. But they gave us the setup, right? 6191 and then 1.04. They told us what the formula is going to look like right away. And what they want us to do is kind of like work backwards and answer those 2 questions. Right, okay, so here's the formula for the number of people, a population, that's why they chose P, since 1990. But look at the question right after that. What is the population in 1990? Well, if the setup for the formula is, okay, starting amount, multiplier or growth factor, and then exponent, if this is 6191, that's the starting amount. It's like they're giving us the answer, but we have to like pull it out of the formula and pick which number means what. So that's why we look back here. All I did was I wrote population 5100. Go ahead, write that. Something like that. They gave us the formula and they gave us the starting number and then asked us for the starting number. And then they asked this question, okay, by what percent did the population increase by each year? Right? Well, the rate part of the formula is inside, right? But it's 1 plus the rate. And what is that? 0.04. What's that as a percent? 4. So they're just having to work out, which is kind of nice. It's not get their brain working, which we're going to need in a couple days. Well, let's see. What's today? Tuesday? So tomorrow, compound interest conversation. Thursday, definitely practicing that. Friday, continuous compound interest. Monday, practice that. Tuesday, maybe we'll start solving exponential equations. We'll start off easy, and then they'll take there when we kind of stuff. We'll figure out the tables. So yeah, definitely hold on to this, because we're going to get back to that backside tomorrow, Thursday, Friday, Monday, Tuesday, Wednesday. So we're gonna get after it. So once you're done, you're good. You are free to relax for these last 5 minutes or so. That's a 4.4. Yeah, should be on there with today's due date.
What?
And folks at home, when you are done with that, you guys are good to go. You don't have to stick around. Thank you for showing up, and I will